Hi guys, welcome back to part 2 of the Grasshopper Attractor tutorial. In this tutorial, it's similar to part 1, but I kind of want to show you how to go from sort of this flat plane into a more facade-like design. So first, we're gonna create a hexagonal grid. What I did for this is just search up hexagonal, and not the structure, just a 2D grid. And we're going to make that similar to our rectangle size, 20 by 20. And once you have that, we're going to flatten these two datas of the points and the curves. And what I had from our previous tutorial is just copy and pasted the closest point, so that is our attractor point, and our curve. So our curve is going to be our attractor point, and then the remapping of the distances between the points and remapping it into between the values of 0 to 1 and then remapping it back again, so then we could have our sort of own control over what those distances look like. So you can see it's kind of orange here. If you copy and paste it, it might be connected still to the area and the closest point, but what we want for this hexagonal structure are the points of these cells, and we're going to plug it in, and now that's going to measure the distance between this curve right here and the points in the middle of all these cells. And what we want to change with the attractor is sort of the scale of these sizes. So we're going to search up scale. Let's plug in our curve there, plug in our points there, so you can kind of see now that the scale is being changed, and how it's going to be manipulated with the curve is through a remap, and we're just going to plug in that there. So now you can see that if we move this around, it'll move around as well with the scale. Let's make maybe this one a bit bigger. Okay. So now since we have this, we want to kind of put it into a surface. So what we want to do is first extrude this, just polylines or curvilinear component. So first we're going to get the edges of these things. Let's merge, search up merge, and we're going to grab that geometry and also the initial hexagonal grid geometry, and that's gonna merge into sort of one component over here. And we're gonna make this into a surface by getting its boundaries and making it into surfaces. You can kind of see it's turning into surfaces over here. Then let's graph this. And let's graph this, still a little bit more accurate. I kind of want the bigger holes, so let's play around with that, and let's just make this sort of bigger. So now we have a surface, and we want to now extrude that surface. So let's extrude it into, just extrude into the Z direction. Can kind of see now it is more solid, and since we are in meters, let's make it like half a meter. And now on Rhino, I'm gonna go top view for now, and then just construct a line, whatever line you'd like. And we're going to make that into an extruded surface. So click on your line, and you could type extrude curve, or you can kind of just drag this dot over here, and I'm just going to drag it into, put shaded on. You can see that's a surface now. And on Grasshopper, to get that surface into here, we'll just type in brep or surface. set that as this. Now we have that. Now what I want to show you is how to get this onto this surface over here. So how to do that is through surface morph. We're gonna want to put this in a box. So we're gonna do a bounding box, and then we're gonna plug in our content. But now we can see here it's per object, and that's gonna kind of sort of be messed up once we plug it into surface morph, and I'll show you in a bit. So we're gonna search up surface morph. It's kind of this really long component. So here is the geometry to deform. We want to deform our flat geometry, and let's plug that in over here. And then the reference is the box that we have, and the surface to map onto is this. And the UV should come from the bref, so we're just going to construct a domain. Nope, not that one. We're going to deconstruct the domain, not construct. So we're going to deconstruct this surface into the U and V direction. And you can see we're going to have different values for that. We'll plug in the U, plug in the V. And for the W, it's the surface space W extent, and I just plug in the Z to kind of, so it follows that directionality of extrusion. And it might take a minute over here. Okay, I just paused. It took around 10 seconds for it to load. And now you can kind of see that it's kind of weird. It's only placing hexagons on top of each other instead of the same pattern along the surface. So what could fix that is, I'm gonna lock the solver right here just in case it will lag, is to change the bounding box from per object into a union box. And we're gonna unlock it. Right, so that took a couple of seconds, but a little bit of troubleshooting. We just want to flatten this extrusion over here for our data to be in one list, and then it will turn out sort of like this. I'm going to hide everything and also hide this. Now we can kind of see it is following that surface that we had earlier. And then with our curved attractor over here, it should respond. It might take a minute. But yeah, you can see it updated and should respond to whatever attractor you have on this sort of closest point component. Yeah. So if you want to sort of do a custom display, turn the preview off, and let's do a swatch. Let's make it like a gray. There you go. So box morph kind of takes whatever we have in the flat plane into maybe a facade sort of treatment. Yeah, thank you guys.